Today we're going to learn how to determine whether a sample represents a population. And along with that, we're also going to talk about how a sample is biased or unbiased and how those samples affect whether a conclusion is valid or invalid. So let's start with some vocabulary. Our first vocabulary word is population. So a population is an entire group of people or objects. So it's the whole thing. So think of population as the whole thing. So if the population is the whole thing, the sample is a part of the population. And you can use a sample to make an inference or a conclusion about the population. Sometimes the population is just too big to survey, and so when that happens, then you take a sample, which is a smaller part of the population, so you can draw a conclusion about the whole thing. So an inference is a conclusion, and you should know that from your ELA classes. So when you make an inference, you're drawing a conclusion. And then down here, we kind of have the steps. So the first thing that we're going to do is we're going to identify the population. So population is what goes in that bubble, and I can't fit it in there, but try to fit it in there. Then from that, we are going to select a sample. Then we're going to interpret the data. So we're going to interpret the data from the sample. So in that bubble goes the word interpret. And then from there, we are going to make an inference about the population. And I'm going to abbreviate population with the POP. If that doesn't make sense to you, write the word population out. So you have your entire population, you select a sample, then you interpret the data from that sample, and then from the data you make an inference about the entire population. So that's kind of the flow chart of how this works. You've probably talked in Ms. Bonder's class about samples that are unbiased and samples that are biased. When you are selecting a sample from a population, there are three things that you want to make sure happen so that you have an unbiased sample. You want your samples to be unbiased. And so to make sure that that happens, the first thing you want to make sure is it represents the population. The second thing, you want to make sure that it's selected at random. And then the last thing is you want to make sure your sample is large enough to provide accurate data about the population. So if you have those three things, that will ensure that you have an unbiased sample. Alright, so a biased sample is what you do not want, because it is not representative of the population, and that's because one or more parts of the population are favored over others. So you want to make sure that your sample is unbiased, not biased. And what happens is if you have a biased sample, then your conclusions or a conclusion that you're making will be invalid with a biased sample. So here are a couple of key ideas. The first key idea is the results of an unbiased sample are proportional to results of the population. So you can use an unbiased sample to make predictions. So here we go back to proportions. So think about a proportion is comparing two things and all of that stuff that we learned about proportions. Kind of jog your memory with that. Okay, then the second key idea is biased samples are not representative of populations. Do not use biased samples to make predictions because your predictions may not be valid. So I think in case you're not getting all of this, the thing that you need to keep in mind is you want an unbiased sample for conclusions and to make predictions. And then you need to remember that biased samples are not representative of the population. They should not be used to make predictions, and your conclusions may not be valid. So let's look at our first example, identifying an unbiased sample. You want to estimate the number of students in a high school who ride the school bus. Which sample is unbiased? Okay, so let's look at number A, or letter A. 4 students in the hallway. That is not a good sample because it's too small. So if you are wanting to know of an entire high school, the population is an entire high school who rides the bus, 4 students in the hallway is too small of a sample. Okay, so let's look at letter B. Letter B says all students in the marching band. That is not a good sample because it's not random. You're only, that would be favoring one group, so it's not representative of the entire population. Then let's look at letter C, 50 seniors at random. That is not a good sample because it doesn't represent the population. So let's say not representative of population. Seniors might be more likely to drive than, say, freshmen, because freshmen don't have their driver's license and seniors do. So then let's look at the last one. The last one says 100 students at random during lunch. That is an unbiased sample. It's random. It's large enough. And it represents the entire population. I think in high school you don't have like we do in middle school where 6th grade goes together, everybody goes together at the same time. So D is your best choice for that one. All right, you have a couple of on your own. Do those and then come back and check your answers. All right, it says you want to estimate the number of seniors in a high school who ride the school bus. Which sample is unbiased? So if you look at those choices from above, choice C for this one would be the best choice because it's all seniors. So choice C is unbiased. It's random. Represents the seniors. So REP is represents. If that doesn't make sense to you, write it out. And then it's a large enough sample. So it meets those 3 criteria that we wrote down earlier. All right, and then number 2 on your own says you want to estimate the number of 8th grade students in your school who consider it relaxing to listen to music. You randomly survey 15 members of the band. Your friend surveys every 5th student whose name appears on an alphabetical list of 8th graders. Which sample is unbiased? Your friend's survey is unbiased. Your survey, if you survey members of the band, they might be more likely to relax to music since they play in the band. So your friend's survey is the better choice because yours is only choosing, it's one group of the entire population. All right, let's look at example 2, determining whether conclusions are valid. You want to know how the residents of your town feel about adding a new stop sign. Determine whether each conclusion is valid. You survey 20 residents who live closest to the new sign. 15 support the sign and 5 do not. You conclude that 75% of the residents of your town support the new sign. Well, this is your sample is not representative because residents who live closest to the stop sign may be more likely to support it. So your sample is biased and your conclusion is invalid. Okay, so I just wrote down my explanation. The point that you really want to make sure that you understand is that if your sample is biased, your conclusion is invalid. And so residents who live closer to the stop sign are more likely to support it. Invalid conclusion because your sample is biased. All right, so Part B says you survey 100 residents at random. 40 support the new sign and 60 do not. So you conclude that 40% of the residents of your town support the new sign. All right, so this is a random sample. It's large enough, and it represents the town because you just randomly surveyed them. You didn't pick a particular group. So your sample is unbiased, which means your conclusion is probably valid. Okay, so kind of look at the difference between example A and example B and kind of figure out in your mind how you're going to connect an unbiased sample gives you a valid conclusion. Example 3 is making predictions. You ask 75 randomly chosen students how many movies they watch each week. There are 1,200 students in the school. Predict the number of students in the school who watch one movie each week. So we want to know which student watches one movie out of the total. And we look at our circle graph. And one movie, we have 21 students out of 75 surveyed. Okay, so I got the 75 here and I got the 21 here. Then I'm trying to find, I'm going to make a prediction of my whole population at school. Alright, so I've set up a proportion. This should look familiar. Cross the equal sign and multiply. Cross the equal sign and multiply. I'm going to do 21 times 1,200 on my calculator. When I do that, I get 25,200. Divide both sides by 75. And when I do the math, then I get 336 students. So I can estimate that about 336 students watch one movie a week. All right, and so this should feel very familiar. We've done this before. This should not be anything new. Go ahead and do the on your own and then come back and check your work. All right, hopefully you've done the on your own. It says in example 2, each of the 25 randomly chosen firefighters support the new sign. So you conclude that 100% of the residents of your town support the new sign. Is this conclusion valid? Okay, so even though it says randomly, they are still randomly choosing firefighters. So that's only one group within the population. So no, this is not an unbiased sample. This is a biased sample. And so the conclusion is not valid. Firefighters are more likely to support the sign for safety concerns. So even though it says randomly, it doesn't matter because it's focused on a particular group of people. So my sample is biased, which gives me an invalid conclusion. All right, then in example 3, it says predict the number of students in the school who watch 2 or more movies each week. So we have 2 out of the total. It looks like 24 students watch 2 or more movies a week out of the 75 who were surveyed. And then the rest of it's going to be the same. Cross the equal sign and multiply. Cross the equal sign and multiply. When I do that on my calculator, I get 28,800. Divide both sides by 75. X equals 384 students watch 2 or more movies a week. All right, if you have any questions after watching this lesson, please come see me.